Okay, today we're presenting transfer learning in medical images, exploring its impact on model accuracy for breast tumor classification. This project is done by Inad Qureshi and Abdurrahman Sumeh. So the problem of breast diagnosis can be summarized into 2 points, which are the first point is the psychological impact, where the diagnosis of breast cancer can also have a significant psychological impact on patients. The second problem statement is inadequate follow-up even after diagnosis and treatment. Inadequate follow-up care can lead to missed recurrence or new cancer. These problems need to be solved because early detection and accurate diagnosis are curricular for effective breast cancer treatment and better outcomes. Also, improving the breast cancer diagnosis can reduce unnecessary procedures. Before we move on, we need to understand what is transfer learning. So transfer learning is a technique that uses a pre-trained model on a large dataset to train on a small or new smaller dataset. This saves time and resources by reusing features and fine-tuning them for the new task. It is widely used in machine learning for faster training and better performance on smaller datasets in areas such as computer vision and natural language processing. Another concept needed to be understood is image classification, which is a task that categorizes an image into predefined classes. The proposed approach in this study differs from previous studies in two main aspects. Transfer learning in breast cancer images classification involves leveraging pre-trained models that have learned feature from a large dataset of images, such as those from ImageNet. By using transfer learning, the pre-trained model can be fine-tuned in a small dataset of breast cancer images, even when labeled dataset is limited. This allows the model to learn the distinguish features of breast cancer and accurately detect it in images. The breast cancer images also can exhibit variability between patients due to factors such as differences in imaging devices, the patient's demographic and position of the breast during imaging. This interpatient variability can make it challenging to develop accurate and robust classification models for breast cancer. In this task, transfer learning can help overcome this challenge by leveraging pre-trained models that have learned to recognize common features in images from different resources. The methodology in this project can be summarized into 5 main stages. First is selecting 2 different models used for image classifications. Second is train 4 models by using large and small dataset. For example, YOLO 5 is a case study. The third stage is training the 4 different models, and fine-tuning involves using transfer learning to adjust the pre-trained weights of the model to improve their performance on a specific problem domain. This is typically done by adjusting the hyperparameter of the model, such as learning rate, number of books, and regularization, training, and retraining the model on the new data to improve its accuracy and efficiency. Number 4 is investigating the effects of fine-tuning on the model's accuracy. Alone involves measuring the model's performance before and after fine-tuning on the small dataset test to isolate the impact of fine-tuning from other factors that may affect the accuracy of the model. Last is find the best fine-tuning techniques that works better with ultrasound images for breast cancer diagnosis. I will leave the mic for Abdurrahman to continue the presentation.
Thank you, Anad. Can you hear me?
Yes.
Could you go to the next slide, please? Okay, so I'm going to talk about the data preparation. The first step indicating the number of images and presented in two different data sets. A small data set with 502 images and large data set with 788. This information gives an idea of the size and the complexity of the data set, which can impact the performance and the accuracy of the machine learning model trained in these data set. After obtaining the data set, we divided the data set in three parts: training, validation, and testing. This is a common practice in machine learning to evaluate and perform a model with an unseen data. So we divided the data set to 70, 20, and 10 ratio, where 70% of data was used for the training and 20% for the validation and 10% for the testing. This will ensure our model is trained enough on the data and validated with the hyperparameter tuning, and finally tested on unseen data to access the model accuracy and generalization capabilities. The data that we got was in the PNG formatted. Since we used the YOLO model required the data to be converted to the GPG formatted. That things that we did with one of the process when we processed the data. Next, please. For the result, the first step involved training the YOLO V5 models in two dataset, one in large and one in small. The model were trained from scratch, which means that the weight and the parameter were initialized randomly and then optimized using the training data. After training, the second model was created, which utilized transfer learning. And the transfer learning involved using the knowledge and the parameter learned during the training of the first model and applying it to the second model. This lead to faster training and better performance in the new data set, as the model has already learned the feature that are useful for the object detections. Next, please. So here we have the data set, the result for our models. As you see that the project is not completed, we have run YOLO version 0.5 for a small data set and a large data set, and the model weight was 0.24 and the speed was 0.004 for the small model for the small data set and 0.006 for the large data set. The model achieved an accuracy of 49%, and the differences between these two are significantly higher. If you look at the right and the transfer learning YOLO 5.05, we receive for the small data set, we see that 54.7 for the model accuracy, and the model weight is the same and the speed are the same. Next, please. The upcoming work, what we're going to do is we're gonna repeat the process using the same classification model, which can help improve the performance and the accuracy for the models, as well as reduce the computation resources required to run them. Using a smaller model can also make it easier to understand and interpret the result. Interrupt the result, which can particularly import the applications such as in medical diagnosis. And also we're going to run YOLO V8 in the small data set and the large data set, and we're going to do the transfer learning for the V8. Next. Thank you very much for listening to our presentation. Please, if you